A warm good morning to my dear students. So today we will see a particular case in the topic dynamics of particles. Let me explain the particular case. So there are two trains. Let me name the train, one train as A, another train as B. So the two trains, they leave the same station, but they move on the parallel lines. So the train A starts with a uniform acceleration of 0.15 meter per second square, and it is going to attain a speed of 24 kilometer per hour. And after attaining that particular speed of 24 kilometer per hour, the speed of the train remains constant. Whereas the train B leaves 40 seconds after the train A has left. But it goes with the uniform acceleration of 0.3 meter per second square, and it reaches a maximum velocity of 48 kilometer per hour. After that, the speed of train B also remains constant. Now, the case for this particular problem is, when will this train B will be overtaking train A? Now we'll go for the analysis of this particular case. So the train A starts from rest. So the initial velocity of train A is going to be 0. And it attains a speed of 24 kilometer per hour, which is equal to 6.67 meter per second, which is equal to 6.67 meter per second. Now the train A is going to have a constant acceleration of 0.15 meter per second square. So now I am taking T as the time taken when train B is going to overtake train A from its start. So the time of train A is taken as TA. Now to attain a speed of 6.67 meter per second, the time taken by A is TA. Now we know that the velocity of train A is equal to its initial velocity plus the product of acceleration into time. So the velocity we have found it as 6.67. The train A starts from rest, so its initial velocity is going to be 0. And it is having a constant acceleration of 0.15 meter per second square. So now we equating this, we are able to find the time taken by train A, which is equal to 44.67 seconds. Now, the distance traveled by train B in this particular time of 44.7 seconds. So what is this distance? Now, distance is equal to velocity into time plus acceleration into time square. So now, S is equal to, again this velocity is at start of train B is equal to 0. So, the term gets removed. Acceleration is 0.5 for train B and the time taken is 44.47. So now distance traveled by train B in this total t seconds is equal to 296.63 plus 13.34 into t minus 40, because train B has started 44.4 seconds later train A, so t minus 44.47 minus the time taken by train B. So from this, by solving, we get the time as 82.28 seconds. 82.28 seconds. Now we choose the next case. Now there is a car A which accelerates uniformly from rest on a straight road. Then car B starting from the same point 6 seconds later with the initial velocity accelerates at 6 meter per second square. Now the car A has been overtaken by car B 400 meters after the starting point. Now what will be the acceleration of car A? That is what we have to find out. Now car A accelerates uniformly from rest. So initial velocity of car A is equal to 0. Now initial velocity of car B is also equal to 0 because it is also starting from rest, but it starts 6 seconds later. Now acceleration of car B is given, it is given as 6 meter per second square. Now the B overtakes A after 400 meters from the starting point. So the distance covered by A and B during overtaking is going to be equal to 400 meters. That is distance covered by A, SA, and distance covered by B, SB, both are equal to 400 meters. Now we have to determine the acceleration of car A. Now I am assuming that time taken by car A when it reaches the overtaking point 600 meters is TA. Car B starts 6 seconds later and reaches this 400 meters to overtake car A. So the TB is the time taken by car B. So it has started 6 seconds later. So TB is equal to TA minus 6. Now I am considering the motion of car A. So I am applying the equation S is equal to UT plus half AT square. Now S is known 400 meters. Car A starts from rest, so velocity, initial velocity is 0. So half into acceleration of A into TA square. Now acceleration of A into TA square is equal to 800 because the 2 is gone to the next side, so it becomes 800. Now I am considering motion of car B. So car B also going to cover the same distance, so it's 400. Initial velocity of car B is also 0, so the term gets eliminated. Now half into acceleration of car B is 6 into TA, TB is equal to TA minus 6 the whole square. Now from this we get an equation TA minus TA square minus 12 TA minus 97.33 equal to 0, and solving this quadratic equation we get the time taken by A to cover this distance of 400 meters as 17.54 seconds. Now going and substituting the 17.54 in equation 1, we get the acceleration of car A as 2.6 meter per second square. Now we have to determine the acceleration of A is found as 2.6 meters per second square. Now if you want to find the time taken by B, so which is nothing but TA minus 6. So TA we found it as 17.44. So minus 6 seconds, which will give you TB, which is equal to 11.54 seconds. So now by using the equation of motion, we can analyze the motion of any particle and we can determine either its velocity or time or distance. So we have to remember these three basic equations. V is equal to U plus AT, S is equal to UT plus half AT square, and V square equal to U square plus 2AS. So these three equations of motions can be very well applied to solve any case problems. Thank you.